So first I'll paste the code, then we will discuss line by line. Yeah. So can you just tell me like initial few lines which already we have discussed? So you can tell me those lines and the rest of the lines. Area reset code, what it does?
So it sets the area for the code.
Yes. So it
So
says
and
that
then
like this
move
is,
R3, R3 will hold the value of 0, and
it will hold value 0. Yes, it will be 0. Okay.
so that,
What is the
and
mean?
R0 will hold the address of number 1.
Correct. So if we store number 1 in some memory, so that address it is going to be holded in R0. Correct.
Yes, sir.
Yeah. Then
So and then R0 will contain the contents of value number 4, which will be stored in R1.
no, something else. Can think of it like we discussed yesterday.
So no, like that line is a little bit confusing.
So it is basically loading the value R0, total 4 bytes of data. Okay, 4 bytes of data will be loaded from R0. Okay, so here R2. So
So here
remaining
R2,
R2 will be loaded with
R0 will
R0.
contain, yeah, sir.
In the sense, actually, this 4 hash 4 is the offset. Okay, so if you have like num1 here, so R0 contains the address of num1, right? So here num1 plus 4, right? This address will be there. So that 4 is the offset. So that offset value, with that offset value, R1 will be loaded, and now number 1 value will be loaded to R2. Okay, so these two is added. I mean, those two is loaded. Then what happens?
So and then we have to subtract R1 from R2, and so what is the function of add PL?
It is adding, and what is a PL actually? Yesterday we had seen comparison operative, right? Operations.
Yes, sir. So but we hadn't come across the PL one.
Plus or negative we had seen, right? Plus, PL means plus. Do you remember? In the comparison, we had seen something like PL as the state. Do you remember?
Yes, sir.
PL or MI. So it is actually, it means PL is clearing the negative flag. Okay. It means like number
Yes.
is positive. It represents number is positive. Correct?
So then that line will tell that R3 contains the value of 0, which will be added with the value of 1.
Yes, R3 will be added with 1. Correct.
So the BPL count means. So does BPL stand for binary plus?
No, it's not BPL. Uh, if negative, actually, BPL means if the number is plus. Okay, if the number is plus, then continue the loop. It's a comparison. BPL. If the number is plus, okay, then branch if positive. Okay, branch if positive. And here also add if positive. Okay, branch if positive, it will add only if the number is positive. Okay, so branch PL means add PL means if the number is positive, then it will add. Okay, R3 with 1. Okay, that negative flag. Whenever I subtract, right, R1 with R2, whenever I get a positive result, then only I will add. Okay, so
Yes.
finally, whenever that is positive, then only the loop will be keep continuing. So see, basic funda behind this logic, right? Basic funda behind this logic. What do you mean by division? Whenever I say 4 by, okay, now we'll take bigger number, 16 by 4. What is the meaning of this actually?
So 16 is divided by 4, which leaves us with the answer of 4.
But actual process of dividing is nothing but, can I do it this way? 16 minus 4 I will do. Okay, then I will get
So
12.
we won't get the answer. Yeah.
16 minus 4 is 12. Then I'll get, I mean, how many times I have subtracted, I have to keep counting. I have subtracted one time. So again, 12 minus 4. What is the answer? I got 8.
Sorry. Yeah.
Second time. Then again, 8 minus 4, 4. Then a third time. So then 4 minus 4, I got 0. Fourth
Fourth
time.
time.
Then 0 minus 4. Basically, I got the negative, right? Here we got the negative answer. So what I have to do? I have to stop here. I mean, I have to, if I am adding only if the number is positive, right? So when I subtracted here, I got negative, right? Not increment. So my R3 will stop at 4, correct? Because every
Yes, sir.
positive result, I am keep incrementing R3. So till R3 became 4. So this is actually all R3 values. So till here it became 4. So that is nothing but 16 by 4 only, right? Result.
Yes, sir.
16 by 4 is 4. So that's what we got. Hope you got the idea.
Yes, sir.
See, this is, see, we don't have, I mean, in the ARM, we don't have division operation, right? So that's where it's not a CISC processor. This is a RISC processor. Since we do
So the
not have division,
multiplication, it's done by addition, by
right,
adding those many
right,
numbers.
right. Multiplication we can do by repeated addition.
Got it, sir.
Yeah. So here
And
I'm
later
loading.
in the, yes, sir.
Yeah. Finally, I'm loading some address. I'm saying like R0, I'm loading with address. It is 4000 32-bit address. And I'm saying that R0 plus that address will store the value of R3. R3 is a result. So finally, I'm storing the R3 result. Okay. Then stop it. And here, DCD. Do you remember yesterday we discussed one DCD? What is that?
Yes, sir. So it's double count decimal.
No. Define constant double word. Right? So this actually
Yeah,
I'm
yes, sir.
in this I'm performing 9 by 3. Okay, so 9 by 3. 9 and 3 are the two words I'm defining. So I'm doing the operation 9 by 3. Simple, right?
Yes, sir.
So this actually, when we deal with the RISC processor, we should know these tricks. So what is the meaning of multiplication by 2? Yesterday I gave you some tricks, right? The shifting, left shift, right shift. Basically, it multiplies and divide, right? So those are the tricks you have to understand.
Got it, sir.
Okay. So here we have an question. a set of n 32 bit signed numbers which represent basically temperature are stored in the flash memory. Okay, at the location temp. Okay, so we have to apply the to all those 32 numbers. We have to apply this actually x by 2 plus 3 using assembly level program, and finally the result also we have to move into some memory. Okay,
So how do we write the code for this question?
yes, can you just help me with this? So you can think of it, so then I'll guide you. Okay?
So first is area reset code. I said I didn't understand the last term. It's x by 2 plus 3.
Correct. So any numbers are there, right? So for example, this 32 n32 numbers are there, right? For each numbers, like for example, if I have 5, 6, 9, 10, 3, these 5 numbers are stored. So each number I have to apply this formula, like 5 by 2 plus 3, 6 by 2 plus 3, like this you have to apply for each formula, each temperature value.
So this seems a lot harder than the other codes.
Yeah. So let me assume n as some number 5. Okay. So first we will be like writing area stuff, area reset code, then entry. Let me straightforward paste that code. Then we will discuss that. So here, what I'm doing, I'm loading the address of temp where I have stored 5 numbers. If you see here, DCD 3040F090. These are the value which I have stored in the memory. Correct?
Yes, sir.
Yeah. So yeah, these are comments. So just expand this. And yeah. Yeah, rest of the code lines, can you explain?
So R0 will hold the address of temp, which is just a temporary variable. No, sir.
Right.
So the LDMI is a new term.
It is load multiple instruction. Okay, LDMIA loads actually contents of like whichever the location we are mapping, right? So that
So
R1
then
minus.
the multiple instructions that will be loaded will be the address of temp, and the value of R1 will be subtracted from R5.
No, actually, what it is doing, so whatever the memory location is there in R0, right? So that actually it is 64, okay, 64 bit. It's because since it's a SRAM address. So R1 and R5. So the address will be loaded, whatever stored in R0, right, will be loaded into R1 and R5.
Oh, yes, sir.
Okay.
So what is SP here?
It's stack pointer. Okay. So I mean, like we are starting, we are saying locate our stack pointer to now 0400, this point.
Okay. So, and the STMIA stands for Store Multiple Instruction Stack Pointer.
Yes, store multiple instruction and whatever the stack pointer value is there, again I have to update with R1 and R5. Correct?
Yeah, sure. So, and then R0 will hold the value of so the number written next to it, and R1 will hold the value of 5, and so R2 will contain the contents of R0, and so what is ASR?
Arithmetic shift right, that we discussed, right? Shift right. Why do we shift right? Basically, see, whenever I shift, see now R2, it contains the value of X, right? We have some value. So whenever I shift right by 1 bit, what will happen? Some special functions we discussed, right? It is basically divides that X by 2. Okay. So if I shift right by 2, then it will divide X by 2 square, that is 4. If I right shift by 3, X by 2 cube, that is X by 8. Right. So I mean here I am shifting just 1. So this will become X by 2. Then I am adding R2 plus 3. That is plus 3. X2 by 2 plus 3 I am doing.
Got it, sir.
Okay.
So then,
So
since R2 will have the contents of R0, it will be for that the value of R3, the value of 3 will be added, and R2 will later store the contents of R0, and so
see,
R0 will be
actually,
added to. Yes,
correct.
sir.
Basically, here R1 I have loaded with 5, right? So it will be
Yes,
keep
sir.
decrement. Subtract 1 means it will be keep decrement. 5, 4, 3, 2, 1. Once it becomes negative, that is all the loops are continuing. All the loops are completed. Then this part will become negative and it will stop.
Got it, sir.
Here, basically, if you see here, str is store R2 with 0. That means whatever the value is there in R2, that is a result, I'm storing in R0. And this R0 pointer I'm keep incrementing by 4. That means actually, so initially R0 might be here, 1. So next 4, 8. Like this it will be happening.
Okay, sir.
So next is actually logical instructions. Okay. So in the logical instructions, we have AND, OR, that is ER, okay, all will be 3, XOR, ORR, and BIC.
So does EOR stands for exclusive OR?
Yes, XOR, it is XOR operator.
Okay, so then what does ORR stand for?
Logical OR. So, AND operation, for instance, if I have A and B, so what is the truth table? For example, if my inputs are 0, 0, 0, 1, 1, 0, 1, 1, can you tell me what is the outputs for
So
0,
it will
0,
be
0,
like
1?
0001.
Correct. So if it is OR operation, then what will be the output?
So it will be 0111.
Correct. What about XOR?
So
Exclusive OR?
it will be 0110.
Right. So this is actually XOR operator, exclusive OR. And ORR is logical OR. Okay.
So then
And
BIC is
BIC,
binary bit comparator.
No, it is bit clear. Bit clear.
Yes, sir.
Okay. So in the bit clear, it is little tricky. So what it does, so if I say bit clear, R0 and R1, right? What it does is R0 and not of R1. Okay, it does this operation. R0 and not of R1. Bitwise not. Okay.
Sir, I didn't get the bitwise properly. Can you please repeat it?
Okay. So if I say BIC R1, R2, R3. Okay. So it what it does is the result will be stored in R1. What result? R2 and not of R3. That is entire bits, right? It will complement. Not of R3. Did you get it? What is the meaning of not of R3?
Yes, sir.
Got it, right?
Yeah.
So we have some pseudo comparison operators. Okay? Pseudo comparison operators. They are CMP, TST, and TEQ. So CMP basically compares two registers and updates the plan. Okay. If I have A and B, what it does, A minus B it does. Compares if whether it is equal, greater than or less than. Basically we get when we subtract two number, right? If I have 5 and 6, when I subtract 5 minus 6, if I get minus 1, then 5 is lesser than 6. If I get positive number, it means 5 is greater than 6. If I get 0, then 5 equals to 6. I mean, like the number, not 5 equals 6, but two numbers are equal. So that's where internally it does some subtraction and it checks the flag. So comparison, basically it compares. So TSD, it does the XOR of two register and updates the. Okay. TSD, it does the AND of two operators, two variables, and updates the flag. TEQ does XOR of two register and updates the flag. Okay.
Yes, sir.
So here I have a small example program. So you have to tell what is the status. So you can explain me. So if wrong, I'll correct you. Hello.
Yes, sir.
Yeah, you can explain this code, and if wrong, I'll correct you.
Okay. So first R3 will contain the value of 0, then R0 will contain the value of 5, then R1 will contain the value of 5, and TEQ is an XOR operation which will be performed on R1 and R0. And
What will happen here?
I said it'll come as equal because it both of them contain the value
So
of 5.
since both has like same value, when you XOR both the, I mean both like same values, then result will be 0. So or equal flag will be set, correct? So 0 flag will be set. So since
Yes, sir.
add if equal, so that is because both are equal. So it will add R3 plus R0. R3 is 0. R0 is
5.
5, correct? And it will stop.
Yes, sir.
Let's see another program. You can start explaining. I'll correct.
So first we set the area for the code, and R0 will contain the address of number, and then R1 will contain the contents of R0. So R0 will. So what is the function of AND mask?
So this is actually address of AND mask. So this is a location. See here, AND mask, whatever we have stored, that defined constant. AND mask is a constant. So FFFE, that is the mask we are storing. So that address I am loading into R0. Now LDR, what I am doing, whatever the content present in this R0, I will load into R. Now what I am doing, I am adding R1 and R2. So R1 is num, that is actually all are 0 that is stored, right? So here I'm
Yeah.
basically adding this num R1 and R2. What is the final result? Final result will be 0, correct?
Yes, sir.
Okay. So here again R mask I am loading to R0.
So
And
it's the
R2
address of
contains,
all mask which is 0 again.
no, R mask is this, right? R mask is 8000, correct?
Oh, yeah, yes, yeah.
Yeah. So this 800 will be loaded here, and R mask like R2 and R1. That actually R1 what it has? It
So
is again
R1
0,
contains 0.
0,
Yeah.
right? So same way, like same way it keep happening actually. Okay? XOR mask and it will XOR and it finally it will stop. So this is like just a demonstration code for showing how that masking works.
Yes, sir.
Next, we will see last program for today. So area reset, this is actually defines the area. It will enter. Then it will actually loads the number. So the question basically, write a program to check for D1 bit of a number. D1 bit of a number. If it is 1, then store value 20 in R3. Else store 10 in R3. Okay. So here first I am loading the number. This is basically DCD 03 I have loaded, right? So I'll load the number into R1. Then I will load the mask, that is 2 into R2. Okay, I'm comparing R1 and R2. D2 means actually, see, numbers will be usually D0, D1, D2, D3, so on, correct? So I am basically comparing which bit? D1, correct? Whether D1 is high or not. So TST, it basically ANDs, right? AND. So what it does, it ANDs R1 and R2. Okay. R1 has 1, 1, correct? So this is my number. And I will AND with 1, 0. 1, 0. So when I AND with 1, 0, if this is not set, D1 is not set, if it is 0, then whole number will become 0, correct? When I AND it.
So, but
So
what does the mask do? Like, they have
mask,
R0 keeps the address of mask,
yeah,
or
mask what it does, right? So see here, now my scope of interest is only D1, correct? Because I have to check whether D1 is high or no, correct?
yeah, sir.
So mask extracts only that bit. See, if you when I AND with this, right, it extracts only this bit, correct? If it is 0, it will show 0. If it is 1, it will show 1. So it is extraction. I mean, you will keep the mask and you will extract. Okay?
Yeah, sir.
Just a second. So here, what I am doing, if both are equal, I mean, that actually, what do you say? Test actually whenever I am ANDing. So R1 and R2, it means actually if the result is 0, equal means if the result is 0, then what I have to do, I have to move 10, right? So I will skip here. I'll skip here. And I move R3 with 10. Okay. Else, here what I am doing, I will move R2 with 20, R3 with 20. This condition. If it is like not 0, that if it is 1, that means due to mask, if it is 1, then I will move R3 with 20. Hope you got the idea. It's a simple logic, right?
Yes, sir.
Any doubt here?
No, sir.
Okay. Okay, then. Thank you. We will meet tomorrow then. Okay.
Yes, sir. Thank you, sir.
Thank you. Tomorrow we will discuss on multiplication and yeah, some load and store instruction. LDR and store we have already seen, but we will see in detail load store instruction.
Okay. Thank you, sir.
Okay.